On number 15 here, it says perform the following row operation for the given augmented matrix. So -3 times row 1, that's what that first part is saying, plus we're going to add that to row 3, and that becomes the new row 3. So I'm going to go ahead and rewrite the matrix, and I can go ahead and put the first 2 rows in because they're not going to change. And so we're going to multiply -3 times row 1. -3 times 0 is 0. -3 times 1 is -3. And -3 times 2 is -6. And so we're going to add these values to row 3. So 0 and 2 give me 2. -3 and -3 give me -6. And -6 and -4 give me -10. Excuse me. On number 16, it says you construct an open box with a square base from 128 square feet of material. The height of the box is 7 feet. What are the dimensions of the box? So we've got this formula for the surface area, and we're just going to plug in the numbers. So S is for the area. That's 128. And then we'll plug in the height on the other side. And so we're going to get 128 equals x squared plus 28x. And this is a quadratic equation, so we want to get 0 on one side and everything else on the other. So I'll subtract 128 on both sides. We get 0 equals x squared plus 28x minus 128. And hopefully we can factor this. Let's go ahead and try using the AC method. We need two numbers that multiply, or need to find two numbers that multiply to -128 and add to 28. Let's see, 1 times 128, that's not going to get me 28. But how about, and notice I'm making one of them negative. I want the two numbers to add up to a positive number, and so we'll make the smaller one negative. Let's go ahead and try the next one, -2 and 64. Those numbers aren't going to add to 28. And let's see, 3 doesn't work, but 4 divides into 28. It turns out it's 4 times 32. And notice this is the one that's going to work because -4 plus 32 does give you 28. And so let's go ahead and split our b term. And we can factor by grouping now, factor out an x. And we're expecting when we factor here that we'll also have an x minus 4 factor. So we need 32x, so multiply by 32 there. And 32 times -4 does give you the -128. So our common factor is x minus 4. And the other factor will be x plus 32. And we know that when this is a 1, the coefficient of x squared, that we could have just gone straight from here to this point here. But if you do it the longer way, that's fine, whatever you're most comfortable with. Now we're solving an equation here, so this is equal to 0. So when we set each of those equal to 0, we get 4 and -32. And of course, a length can't be negative. And so 4 is going to be the answer here. Remember, the bottom is going to be x by x, or 4 by 4 in this case. So that's our final answer there, 7 by 4 by 4 feet. Let's move on to 17. So it says, answer the following questions about the function f of x graphed to the right. First of all, we have to find the domain. So we go to find domain, we go from the leftmost point to the rightmost point, and we look at x values. So there's my leftmost point, and the x value there is -3. And that point's on the graph, that's why I'm using a square bracket. And then we go to the rightmost point, which is right there, and at that point x is 5. So all we're saying here is all the points on this graph have x values between 0 and 5. Now for the range, we start at the lowest point and we go to the highest point, and I'm sorry, at the lowest point the y value there is -4. Again, with range, we're going lowest to highest point, and we're looking at y values. And so the y value there is -4. At our highest point, the y value is 3. And so the range is -4 to 3, which is just saying that all the points on this graph have y values that go from -4 to 3. Now, we're supposed to talk about where f is increasing, decreasing, and constant. But if you actually look at the graph, as you go from left to right, we keep going down the whole time. This function is increasing the whole time. And so we're decreasing on the whole interval there. Remember, when we describe where we're decreasing, that'll be on an open interval. So it starts when x is at -3, and it goes until x is 5. So remember, this will always be an interval of x values. Anytime you talk about where you're increasing or decreasing or constant, always an open interval. All right, on the other two, C and E there, those don't apply because we're not increasing or constant anywhere. If we're finding f of -2, notice that -2 is an x value or an input. And so we're looking for the point on this graph that has an x value of -2. Well, that's where -2 is, and the point that has an x value of -2 is that one right there. The corresponding y value would be 2. And so f of -2 is 2. Another way to say this is when x is -2, the height of the graph is 2, or the point is up 2 on the graph there. On letter G, we're supposed to find an x value for which f of x equals -2. Remember, f of x is another name for y. And so what we've been given is an output value of -2. So on the graph, we're looking for a point that has a y value of -2. I always like to draw a vertical line that goes through, in this case, -2, and you can see that point right there is where our graph has a y value of -2. The corresponding x value would be +2. I'm sorry, +1. And so x is 1. In fact, you could plug the 1 in. F of 1 does equal -2. When x is 1, the height of the graph, it's down 2. That's -2. All right, if you look at H, some students really struggle with this kind of problem. Inverse functions, there's just some things you have to remember about inverse functions. I'm going to go ahead and write the point that's on the graph of the inverse function. We're looking for, well, this point has an x value or an input of -3. We're looking for the corresponding y value. The thing about it is, if we know an x value for the inverse, then we know a y value for f. And so we know that some point that has -3 as a y value would be a point on the graph of f. All I'm doing really is just switching the x and y values here. And so we need to find the point on the graph of f that has a y value of -3. Well, that's going to happen right there. That's where y is equal to -3, and the corresponding x value is +3. And so the other point that we're looking for is -3, 3, which means f of -3 is 3. Remember, -3 is the input, and 3 is the output for this point that's on the graph of f inverse. All right, let's move on to 18. So there's some things we call this operations on, or function operations. In other words, if you have f plus g of x, that's equal to f of x plus g of x. F plus g of x is a new function that you get by adding the two functions f and g together. Similarly, f minus g of x is f of x minus g of x. F times g of x is f of x times g of x. And f divide g of x is f of x divide g of x. So let's look at A. We know that f of x, or f plus g of x, is f of x plus g of x. Now in this case, our input is not x, it's 3. And so we're just going to replace all these x's with 3's. So f plus g of 3 just means f of 3 plus g of 3. Well, we know how to find f of 3. We just plug 3 into the f function. It'll be 2 times 3 plus 5, and that's going to be 11. So far we've got 11 plus g of 3. Let's plug 3 into the g function. We get 3 minus 4, and that's negative 1. And so we're going to be adding negative 1 here. And so f plus g of 3 is 10. On letter B, we have to find f minus g of x. Well, here we're just using this property up above. So this is f of x minus g of x. Well, what is f of x? That's 2x plus 5. What's g of x? That would be x minus 4. Notice we're subtracting these. The only problem is if I don't put parentheses around my functions, I'm going to make a mistake, because in particular here I'm going to have to distribute the negative. So anytime you're doing subtraction or multiplication as well, you're going to need parentheses around your functions. So this I can drop the parentheses around the 2x plus 5 because there's just a 1 out front. But here I'm multiplying by negative 1, and so I'm going to get a minus x and a plus 4, so that should be plus 4. And then I can combine my like terms. I'm going to get x here, and 5 and 4 is 9. And so that's our output. So notice when I plugged a number in as an input, I ended up with a number as an output. When I plug in a variable as an input, or some variable expression, I'm going to get an output that's a variable expression, normally anyway. All right, f times g of x, we're going to say or write as f of x times g of x. So we're going to do the same thing we just did with subtraction, but this time we're multiplying the function f times the function g. So here we're going to use the FOIL. So we get 2x squared, then a minus 8x, 5x, and a minus 20. And notice you got a couple like terms there. You get 2x squared minus 3x minus 20. For f divide g of negative 2, by definition this means f of negative 2 divide g of negative 2. So let's find f of negative 2. That'd be 2 times negative 2 plus 5. Well, 2 times negative 2 is negative 4, and negative 4 plus 5 is 1. And so our numerator is 1. G of negative 2, we're going to plug negative 2 into the g function. Negative 2 minus 4, well, that's going to be negative 6. And so we get 1 over negative 6. And we normally would move that negative out front. We get negative 1/6. On number 19, we've got two functions here, and we're finding the composition function. We say f of g of x. And I always say if you can say these, then you can remember what they mean. F of g of x means f of g of x. We're plugging g of x as an input into the f function. We sometimes call g of x the inner function. So let's go ahead and plug g of x in. G of x equals 3x plus 2, so that's my input. And we're going to plug that into the f function. And so let me go ahead and make a base, goodness, I can't think of the word right now, but one of those. And let's plug in, so basically that's what the f function does. We're going to square our input, then add 2 times our input, and then subtract 4. A shell is what I was trying to say. So we have a shell here. We're going to plug in 3x plus 2 wherever there was an x. That's our new input. And so now we got some work to do to simplify this. We're going to have to multiply 2 3x plus 2's. So we want to FOIL that out. When you do that, you'll get 9x squared plus 6x plus 6x plus 4. And of course the two 6x terms add up to 12x. And so we're going to have 9x squared plus 12x plus 4. In the middle there, 2 times 3x is 6x, and 2 times 2 is 4. And then don't forget that minus 4 there. And now we're just combining our like terms. We're going to get 9x squared, 12x and 6x, we're going to get 18x. 4 plus 4 minus 4, that's going to give you 4. Alright, one thing we learned is that normally f of g of x does not equal g of f of x, and you'll see that's true here. So this is g of f of x, and so we're going to plug in f of x as an input into the g function. Now the g function, that's here, it triples your input and then you add 2. So we want to triple the input and add 2. There's my shell, and my input there is x squared plus 2x minus 4. And so we're going to have to distribute here to simplify. So 3x squared plus 6x minus 12, that's what we get when we distribute, and then don't forget to bring the 2 down. And negative 12 and 2 is negative 10, so you'll get 3x squared plus 6x minus 10. All right, let's move on to the next page here. So we're solving this inequality, and so there's a few steps we have to do. First of all, we want to find out where this expression is equal to 0, this quadratic expression. And so we're going to have to use the AC method to hopefully factor this. So notice AC here is 12. So we need two numbers that multiply to 12 and add to b, which is negative 8 here. And the numbers that work here are going to be, well, those are our possible factors of 12. But notice 2 and 6 are going to work. But we are going to have to make them both negative. Notice negative 2 times negative 6 is positive 12. And negative 2 plus negative 6 is negative 8. So we can't take a shortcut here because we've got a number other than 1 there. We're going to have to split our b term into negative 2x minus 6x. And now we'll factor by grouping. So here, notice the only thing I can factor out is an x. It'll be x times 3x minus 2. And so when I factor these two terms, I'm expecting a 3x minus 2. So notice to get the negative 6x there, I'm going to have to multiply by negative 2. And negative 2 times negative 2 does give me 4. So we're going to get 3x minus 2 times x minus 2. So remember, we want to know when that equals 0. Let's go ahead and set 3x minus 2 equal to 0. We'll need to add 2 to both sides to get 3x equals 2. And when we divide by 3, we're going to get 2/3. On the other, we can see that we're going to get 2. So there's two ways that we did this type of problem, or I should say there's two methods that we use in the AIM course. One's called the graphing method and one's called the test point method. You should look at the solution that's similar to what we did in class. I'll do the graphing method first for this one here. So basically I'm going to set up a number line. We're doing the graph, but we don't need to show the y-axis. Excuse me, and I'm putting we sometimes call these the critical values. They're the values that make this expression equal 0. Now notice we want to know when 3x squared minus 8x plus 4 is less than or equal to 0. So in this case, we're going to use a solid dot on the number line at these 2 points because they make us equal to 0, and that's going to be part of our answer. Now what we're really doing here is graphing the function f of x equals 3x squared minus 8x plus 4. We want to know where this function is less than 0. We already have where it's equal. That's where our dots are. We know this is a parabola though, and because it's a positive 3 in front of the x squared, we know it opens up. So what we normally do is draw a rough sketch of the parabola. And now we can look at the graph and tell where this this function is going to be less than 0. Or in other words, where 3x squared minus 8x plus 4 will be less than 0. It's going to be where the graph is below the x-axis. So that would be right here. All of these points have y values that are less than 0. In fact, we could even write in 3x squared minus 8x plus 4. It's this area in here where 3x squared minus 8x plus 4 is less than 0. All right, so that occurs when x goes from 2/3 to 2. And so when we write our answer, it's going to look like that. The interval from 2/3 to 2. And again, because we have the solid dots, because those points are where we're equal, and that's part of our solution, we are using the brackets on the end. All right, so that's the graphing technique. Now, if we want to use the test point method, then you would make a number line again, and you would put those same points on the number line, but we're going to choose some test values. So there's 3 intervals here, everything up to 2/3, what's between 2/3 and 2, and then from 2 to infinity. So we want to pick a number in each interval. On the one on the left, something less than 2/3. Well, how about 0? That would be really a nice number to work with. Something between 2/3 and 2. Well, how about 1? And then something between or from 2 or greater than 2. Let's use 3. So basically, I'm going to go ahead and write this in factored form. I want to know when this is less than or equal to 0, which is equal to what we have here. It's just factored form. So I'm going to plug in my test values. So if I plug in 0, I have 3 times 0 minus 2 times 0 minus 2. I want to know if that's less than or equal to 0. Well, 3 times 0 is 0, and 0 minus 2 is negative 2. 0 minus 2 is negative 2. And so negative 2 times negative 2 is 4. And notice 4 is not less than 0, so we say false, and we're not going to shade that region. So now let's plug in 1. 3 times 1 minus 2 times 1 minus 2. I'm just replacing the x's here with 1. And I want to know if that's less than or equal to 0. Well, 3 times 1 minus 2 is 1. And 1 minus 2 is negative 1. 1 times negative 1 is negative 1, and negative 1 is less than or equal to 0, so that's true. And so we're going to shade there. And then when we plug in 3, we'll have 3 times 3 minus 2 times 3 minus 2. So 3 times 3 is 9, and 9 minus 2 is 7. And 3 minus 2, of course, is 1. And 7 is not less than or equal to 0, so this is false. And so we don't shade there. So you can see that the part that's shaded is the numbers starting at 2/3 and going to 2. In other words, if you picked any number in this region, and like an x value of 1 or any other number in there, it would make this inequality less than 0. Of course, the points on the ends are what make us equal to 0. All right, so let's go ahead and do 21 now. Now on 21, we need to get 0 on one side, so let's go ahead and subtract x on both sides first. So you get x squared minus x minus 30 is greater than 0. And let's go ahead and set this equal to 0 to find our 2 critical values, or the points we're going to put on our graph or on the number line. So when you factor this, you get x minus 6 times x plus 5, which means x is either 6 or negative 5. So this time I'm going to use the test point method first. If you want to see the graphing technique, then just forward it to that point. Forward the video to that point. So here's my number line. Now notice this time I want to know when x squared minus x minus 30 is strictly greater than 0. Where we're equal is not included, it will not be included in our solution. We want to know when x squared minus x minus 30 is greater than 0. So we're going to use open circle on the points here because these will not be part of the solution. Again, that's where we're equal to 0, which is not part of our solution. And our test values, I would choose -6, 0, and 7. You can choose any values in the interval. If one works, they'll all work. If one doesn't work, none of the others will work. Now, let's go ahead and write the factored form. We want to know if we're greater than 0 when we plug in -6. -6 minus 6 times -6 plus 5. I want to know if that's greater than 0. -6 minus 6 is -12, and -6 plus 5 is -1. So that's 12, and 12 is greater than 0, so we're going to shade there. That would be true, so we're shading that region. If we plug in 0, we have 0 minus 6 times 0 plus 5, and we want to know if that's greater than 0. And we're going to get -6 times 5, and that would be -30. That is not greater than 0. We'd say that's false. And so we won't shade there. And then finally, let's try 7. 7 minus 6 times 7 plus 5. I want to know if that's greater than 0. And so that's 1 times 12. And 12 is greater than 0, so that's true. And we shade there. And so our solution is going from left to right, -infinity to -5. And then we're going to union that with, let's see, starting at 6 to infinity. Notice we're not including -5 and 6 because, again, that's where we're equal to 0, and that's not part of our solution here. Now, if instead of doing the test point method you did the graphing method, you would want to start out the same way. So we're basically graphing the graph of f of x equals x squared minus x minus 30. And so that's going to open up because we have a 1x squared, 1 is positive. And we want to shade, since we want to know where we're greater than 0, we want to shade above the x-axis. And so all the y values there are positive, and the same for those points there. It starts basically from -infinity to -5, and then it goes from 6 to infinity if we're looking at the x values, which is what we're looking at here. And so you do get the same answer. And let's go ahead and stop here.